So we continue with the chapter reflection of light, and now we are on the third part of the chapter, that is related to spherical mirrors and in image formation and their uses. So we are going to have the spherical mirrors. So first of all, we'll discuss about what are the spherical mirrors and what kind of spherical mirrors are there, and what we'll also have some different definite terms which are going to be there in the spherical mirrors. We are going to understand those terms. Then we'll be having the ray diagrams for the different kinds of positions of the object and the images formed in front of a concave or a convex mirror. And finally is the sign convention, which is based on numericals, which is upon the fact that if the object is placed at a particular distance from the mirror, then where will be the image formed. So this is the general idea about the chapter. So we start with the first thing, and that is the different kinds of spherical mirrors and how are they. So a spherical mirror is made by silvering a part of a hollow glass sphere. Thus, a reflecting surface which is part of the sphere is called as a spherical mirror. So if I consider that this is a sphere, okay, this is a sphere, then if I just cut it out like this and do one thing, that on one side I am going to coat it from outside. So this is my opaque surface and this is the reflecting surface. So this is the reflecting surface. And in the other case, I am going to coat it from inside such that this is the reflecting surface. Then these are the two kinds of spherical mirrors. Okay, this one over here, in which the outer surface, the inner surface which is curved, with the inner surface where the inner surface is going to be reflecting surface, is called as concave. Okay, inner, ये inner part अगर मैं ऐसे देख सकता हूँ, inner part है तो it is concave. If it is like this, outer curved part like this, then it is convex. Okay, this is like a cave. Like a cave, right? Concave. So concave. Okay, if I am able to see inside here, it is concave. Okay, when it is like this, it is convex. I am outside the thing, it is convex. Right? So types of spherical mirrors, depending on whether the inner or outer surface of the sphere is silvered, spherical mirrors are of two types, the concave mirror and the convex mirror. In figure 7.2, the right part X of the hollow sphere is silvered and coated on its outer surface. So here in the outer surface, it is coated on the outer surface. Coated on the outer surface. It is coated on the outer hollow sphere is coated on the outer surface and forms a concave mirror, while the left part Y of the sphere is silvered and coated on the inner surface and forms the convex mirror. Okay, I have drawn it in ulta manner. As per the textbook, it was convex here and concave here. But only thing is that here outer surface is coated in concave, inner surface coated with convex. That is the main thing over here. Whether left या right को छोड़ दो, अगर मैंने outer surface को मैंने coat किया तो the mirror formed is concave. मैंने inner surface को coat किया, then the mirror formed is convex. A concave mirror is made by silvering the outer or bulging surface of the piece of hollow sphere such that the reflection takes place from the hollow or concave surface of as shown in the figure. In convex mirror, convex mirror is made by silvering the inner surface of the piece of the hollow sphere such that the reflection takes place from the outer bulging surface of the figure as shown. Okay. So this was about the convex and concave mirror. Concave, convex. Outer convex, inner concave. Reflecting surface inner रहेगा तो concave. Coating outside concave. Reflecting surface बाहर से है या coating अंदर से है तो convex. Now all these mirrors, spherical mirrors which are there, they are a part of the sphere. So whatever are the geometrical parts of that sphere also becomes a geometrical part of this particular mirror. Accordingly, we'll be having certain terms which are very important to learn by heart. So if we consider that this is a sphere, forget this concave and convex right now. We are taking this sphere. So in this sphere, first thing is this center C. The center C is called as the center of curvature. Okay, this is center of curvature. So what is center of curvature? The center of curvature of a mirror is the center of the sphere of which the mirror is a part. Okay, center of curvature is of a mirror is the center of the sphere of which the mirror is a part, is called as the center of curvature. It is represented by a symbol C. The normal at any point of the mirror passes through the center of curvature C. In other words, a line joining any point on the surface of the mirror to the center of curvature C will be normal to the surface of the mirror at that point. Remember this thing, that any particular line I am drawing from C connected to any point on the circumference of this particular circle will be acting as a normal. So this is normal. नॉर्मल यानी क्या, जहां से इंसिडेंट एंगल एंड रिफ्लेक्टेड एंगल सेम मिलेगा, वो वाला नॉर्मल, यानी ये है परपेंडिकुलर टू दिस पॉइंट. ओके, so this is a normal. This here could be normal. So these are just normal. So any line which is passing through the C will be acting as a normal. The next is radius of curvature. So distance between from here to here, this distance is the radius of curvature, given as the radius of which the sphere of which the spherical mirror is a part. The radius of the sphere of which the spherical mirror is a part is called as the radius of curvature of the mirror. Thus, it is distance of the center of the curvature C from any point on the surface of the mirror. Distance PC is the radius of the curvature. It is represented by the symbol R. So this distance is represented by R. Next is pole. Now, if this is the mirror, the center, exactly geometrical center of this mirror, okay, the geometrical center of यहाँ से लेकर यहाँ तक का जो center of the mirror है. So, example, if this is the mirror, then the center of the mirror. If this is the mirror, then center of this mirror. The geometrical center of the spherical mirror is called as the pole. The geometric center of the spherical surface of the mirror is called as the pole of the mirror. In the central point of the surface of the mirror, it is represented by letter P as shown. So this is letter P. So PC is the radius, P is the pole, C is the center of curvature, and this is R, which is radius of curvature. Next is aperture. Aperture यानी क्या? The complete reflecting surface. अगर ये mirror है, तो ये पूरा का पूरा अंदर का surface is aperture. ये पूरा का पूरा surface अगर mirrored है, तो ये part is the aperture. A plane surface area of the mirror through which the light ray enters and falls on the mirror is called as aperture. So ये पूरा का पूरा area जहाँ पे कोई भी incident ray गिर सकता है, okay, that particular point is called, that particular area of the mirror is called as aperture. Thus, the mirror shown in the figure, the complete AB is the diameter of the aperture. So yeah, the complete thing, this one to this one, complete thing over here. If I mark it as A, B, then this is P is the center and this is the complete thing as the aperture. The next is the principal axis. It is a straight line joining the pole end of the mirror to the center of curvature. So this pole to center of curvature, this particular line which is joining the pole and the center of curvature, this is principal axis. So the line joining the pole to the center of curvature is called as the principal axis. Line joining the pole to the center of curvature is called as the principal axis. So these are some important terms. Now we see further is reflection of light from a spherical mirror. From a spherical mirror, reflection of light follows the same laws of reflection as the plane surfaces. That is, angle of incidence equal to angle of reflection. So the angle of incidence and the reflected ray, the angle between the angle of incidence and the incident ray and the reflected ray and the normal lies in the same plane. Note, in a spherical mirror, to obtain the direction of the reflected ray for a given incident ray, first draw the normal at the point of incidence. For this, draw the line joining the point of incidence to the center of C. Then draw a line on the other side of the normal, make an angle equal to the angle of incidence, and this line represents the reflected ray. So if I am going to draw anything, and I am going to draw any kind of a ray diagram, so ऐसा हो सकता है कि ये अगर है, this is the reflecting part, and if this is drawn like this, so this is my C. So this I know is the normal. So if a ray of light is coming like this, I need to find out this angle of incidence, and then I need to find out another angle over here R and draw the line like this. So if this is the incident ray, this will be the reflected ray, because this is the normal. This is the incident ray, this is the reflected ray, this is the normal. So this is how we are going to draw this in, but of course don't worry, there are much more simpler things. You don't need to use any protractor or something in this case. Right, so let's see further. So they are given this example over here, so fair enough, that we'll work it out later on. The next thing is focus and focal length. For concave mirror, the rays of light. Now let's see what exactly does it mean, and I'll just explain you in a figure rather than reading out this part, because it is not so convenient to read out something which is in geometrical form. So let's see this particular ray diagram to understand the meaning of this part. Now if I take a concave mirror with this as the pole, this as the center of curvature, and this is the principal axis, it will be seen that if there are rays of light which are coming parallel to it over here like this, so if I join this one to the normal and then I join, suppose I just draw once that this is my normal. So this angle of incidence ke karan, it will give me an angle of reflection, and accordingly it is going to come out like this. Similarly for this also, it is going to come out like this. This one, it is going to come out like this. This one is going to come out like this. This one come out like this. This one come out like this. So it will be seen that all these rays, after reflection, they are going to pass through a point on the principal axis. They are going to pass through a point on the principal axis, and that particular point which is passing on the principal axis, that is called as the focus. It is focus. So in case of a concave mirror, you will find that all the lines of rays are converging at a point. See, all of them converge at a point. So that's why the concave mirror is called as a converging mirror, and the focus which is present over here is a real focus, because the rays of light are actually intersecting at that particular point. Okay, so you can see the focus of a concave mirror is a point on the principal axis through which the light rays incident parallel to the principal axis pass after reflection from the mirror. So after reflection from the mirror, these particular rays of light are going to pass through that point on the principal axis, which is called as the focus of a concave mirror. Now let's see the same example in case of a concave mirror. So in case of a concave mirror, convex mirror, so in a convex mirror, we very well know the center of curvature is over here, C. This is your pole. The rays of light are coming over here like this. So if I draw a normal to this particular point, so I know that this incident ray will be reflected over here like this, because this is I and this will be R. Accordingly, if I draw it for this one, normal, then incident ray, say reflected ray will be like this. So this will be I and this will be, sorry, slightly deflected. That will be like this over here, I and R. If I get this backwards, okay, I'll put it with other colors so that you understand properly. If I bring this thing backwards, sorry, it is somewhere mistake because it's freehand. So this one also is going to go like this, which one backwards goes like this. This one is going to go like this and backwards will go like this. This will go like this. In fact, it will go like this and backwards it is going to go like this. This one go like this and backwards it will go like this. You will find that in case of a convex mirror, the light rays are going to go away from each other. That means they are diverging. The light rays are diverging, and because they are diverging over here, you can see that they seem to intersect each other at a point on the principal axis. This is the focus of a convex mirror, and the convex mirror का जो focus होता है वो virtual होता है. Okay, it's a virtual one. Why? Because there is no actual intersection of these light rays. They are intersecting when they are produced backwards. So that's why this particular kind of the focus of the convex mirror is a virtual focus. The focus of convex mirror is a point on the principal axis from which the light rays incident parallel to the principal axis appear to come after reflection from the mirror. So it is appear to come from after the reflection of the mirror. So that is called as a focus in case of the convex mirror. Now, of course, if this would have been not parallel like this, but in a different manner, you can see that you will be having the image anywhere on this particular line. You can have the image over here, depending upon whether these lines are parallel to the principal axis or it is not parallel to principal axis. If they are not parallel to principal axis, they are going to meet anywhere on this particular surface, and that's why they are called that particular line, that particular plane over here on the focus is called as the focal plane. So a plane passing through the focus and normal to the principal axis of the mirror is called as focal plane. A parallel beam of light incident to the principal axis get focused at a point on this plane. So if they are parallel beam of light but they are not parallel to the principal axis but they are inclined to the principal axis, then they are going to be inclined to the principal axis are going to be passing through this particular plane. So it is a point where the ray passes to the center of the curvature meets the focal plane. So that is the focal plane. Now to convenient rays for construction of ray diagrams. So now we are going to see what are the convenient rays we are going to draw for the drawing of the ray diagram. Now for drawing of the ray diagram, what we will be doing is we are going to take 3 rays from each and every object or point. So that's why we are going to have this particular, you can see you can follow these 3 standard rules of the incident ray to the reflected ray passing. So let's see those 3 rules what we are talking about. We'll take the example of concave mirrors only. Convex में ज़रूरत नहीं है उसका, दिखाने का ज़रूरत नहीं है. Of course it is going to be followed by both concave and convex both, but yeah, देख लेते हैं, not a problem. So I'll just show both of them. Okay, so first of all we have over here concave and we'll be having over here convex. Okay, I'll write over here incident ray, reflected ray. Okay, how is the incident ray and what happens to the reflected ray? So first of all we have this concave mirror and on the other side we have got this convex mirror. Okay, concave, convex. We have this point as point pole, principal axis C. We have got this over here, so we'll take the same C and this is the pole. Okay, this is the pole. C is common for both of them. Just for the sake of it, we don't require it. Now, it will be seen that if I have got a ray which is passing through C, okay, a ray which is passing through C, because the C is also the normal, if any ray is passing through C, then it is also the normal, so the reflected ray will also pass through C. So it is going to be this way, that if there is a ray, so if I got a ray which is passing through C, so we have a ray passing through C, then the reflected ray of this will also pass through C. So if the incident ray is from C, the reflected ray will also from C. Same way over here, if this is the ray which has come over here passing through C, the reflected ray will also pass through C. Okay? If you want, I can do one thing, I can just cut it into two parts so that you have two separate figures and you are not getting confused about the point that how come the C is the same. They are two separate figures altogether. So this one will draw it slightly different than this center. So if this is the condition, then this is going to be like this. So the first condition is, if I got a ray diagram, in a ray diagram, if I got an incident ray which is passing through C, then the reflected ray of that incident ray will also pass through C. That is my first law or first rule which I am going to follow while drawing the ray diagrams. The second law is, if the ray is going to be passing through the a ray which is parallel to the principal axis. So if a ray is parallel to principal axis, so first of all I just mark some over here F, and over here also I'll mark it as F. This is the focus. We know that if the ray of light is parallel to the principal axis, it is going to pass through the focus when it is reflected. Here also, if the ray of light is parallel to the principal axis, it is going to pass through the focus and going to be diverged like this. So this is the next step, that if it is parallel to principal axis, it passes through F. If the ray of light is parallel to principal axis, it will be passing through the focus. Parallel to the principal axis, then it passes through the focus, because this is the principal axis. So this and this are parallel lines. Okay. Parallel to principal axis, passing through focus. The third one is, if it is passing through the focus, then it will become parallel to the principal axis. So if the ray of light is passing through the focus, so if I got a line which is passing through the focus, then after reflection it will become parallel to principal axis. If a ray of light is passing through the focus, then after reflection they become parallel to the principal axis. Understood? Passing through the focus becomes parallel to principal axis. Passing through the focus becomes parallel to the principal axis. So over here, passing through focus becomes parallel to principal axis. So in this way, you can see that whenever there will be any particular ray diagram, I am going to at least consider any two of the three things over here. Passing through the center of curvature, then we will be passing back to the center of curvature. Passing through the parallel to the principal axis will become pass through the focus. Passing the focus become parallel to principal axis. In case it so happens that it is passing through the principal axis, it is passing through P, that is, it is passing through the pole, then of course, because pole is also normal, so it is going to become the angle of incidence will be angle of the angle of reflection. So in such a case, it will be this way, that if this is the angle formed over here, that will be equal angle which will be formed over here. Same way, if it is angle here, the equal angle formed over here. So this is how it is going to be in case of it is hitting at the pole. So a line incident at the pole, if the line is incident at the pole, then it is going to be reflected based on the laws of reflection, that angle of incidence is equal to angle of reflection. So these are the 4 things what we have studied over here. A ray passing through or directed towards the center of curvature of the spherical mirror is reflected back along its own path. Second, a ray incident parallel to the principal axis after reflection from the spherical mirror either passes or appears to coming from the focus. Either passes or appears to be coming from the focus. Third, a ray either incident from the focus or converging at the focus after reflection from the spherical mirror becomes parallel to the principal axis. One, passing through the focus becomes parallel to principal axis, or appearing to be passing through the focus become parallel to principal axis on reflection from the spherical mirror. Fourth point, for a ray incident at a pole of a spherical mirror, the reflected ray is at an angle of reflection equal to the angle of incidence with the principal axis as normal. So this is what the principal axis itself will become the normal. This is the normal. So this will be I will be equal to R. So these are the 4 conditions. So we can say that okay, here for pole we don't need to write over here because I is equals to R is already known to us. So these are the things what we are going to use when we are drawing the ray diagrams for the spherical mirrors. So in the next video we start with the different cases. There are totally 7 cases in case of concave mirrors, and then there will be 2 cases in the convex mirror. So totally we are going to have 9 different ray diagrams drawn for the different conditions or the different there will be totally 9 of them. Convex के 2 है, उन लोग ने एक ही दिया है. Okay, उन लोग ने एक ही दिया है, so we'll draw only 1 of them. So 1 of convex and 7 of concave which are the 8 ray diagrams which we'll be drawing. Okay, in the next video. But fine.